Okay, well, thank you for the opportunity to do this. I love doing these things, and what I find is I learn more from the questions than what I present. So, anytime something comes up, it doesn't sound right, just jump in. Here's who I am. I've been licensed since '71, but only been chasing DX for a few years. I'm involved in all kinds of different stuff. The editor of a couple newsletters, and the Ohio Section Journal and some other things. So I try to keep busy with it, stay on top of it, and I also I don't think it's yeah, the DX Mentor podcast. There's at least one of you in there that we've had on a couple times. I'm always looking for new topics and new amateurs. So there's a quick plug if you want to be on a podcast. We'll get you in there. Very quick shot of the operating position, fairly modest. I have added a hex beam since I took this picture. Unfortunately, I had a 50-foot tree take the hex beam out, so I'm back to this picture, but we'll get it up here shortly. If you want to contact me for any reason, you can certainly do it this way. If you're coming to Dayton and you'd like to come to the DX dinner, I'm the chairman of the dinner and president of the club, so I'll be happy to make sure you get good tickets and chicken that actually tastes good. You may not have known that, but there's two kinds of chickens at the dinner, so I make sure that the people I know get the stuff that tastes good. So feel free to drop me a note. Um, so here's what we need by a 160 meter small space vertical. I'm talking about a total area of approximately 60 feet, a circle 60 feet in diameter. And as it turns out, I'll show you at the end of this some other uses for this. It doesn't even have to be a circle. It can be a half circle. It can be three quarters. And some guys have gotten really good results from it. Um, the antenna itself is really the mind of K6MM, John Miller. If you're not familiar with John, um, he's been a DXer, an operator, a pilot, all kinds of things, very heavily involved in the DX community. And this antenna was his idea. I did talk to him ahead of time. I made a few tweaks, and he was happy and happy to allow me to go out and pass the word. So I have his blessing to do this. I'm not stealing anything. See, I even said it there with his permission. Um, Also, Jim K9YC had some groundbreaking work that he did on radials and ground loss, which I just learned a ton from reading that. He gave me permission to use his stuff as well. Very, very interesting. I thought I knew a lot about radials, and I didn't know anything until I got into it. And then the further I get into this, the more I realize I still don't know anything because there's so many different opinions and so much research that's been done. So it's a really interesting part of antennas in general. So what I consider this is I'm kind of the chef, and I'm just going to use different ingredients and try to come up with a workable antenna to get me on 160. That was the goal. The first time I presented this, I didn't realize there were a lot of people that didn't know anything about 160. So I'll take a few slides and just cover that. And this is the part of the show where I've been doing this 6 or 7 years on 160. And if somebody says, you forgot this, you forgot that, I'd love to hear that. So don't be shy. But in my 6 or 7 years, here's some of the work that I've uncovered. Um, FCC does not regulate the band by mode, so there's a gentleman's agreement, which is part of the reason they call it the gentleman's band. And I have found that everybody does try to pretty much stick to that, and it works very well. And it's really a neat band. There's a lot of neat guys on it. It has interesting operating challenges. Ionospheric absorption is one of them, and refraction is the other. So 160 is a challenge. And it struck me as funny several years ago. There's a guy here, KDV. He's been my 160 mentor. And I spent about 45 minutes digging Switzerland out of the noise. And I called him, and it was like, I don't know, 1:15 in the morning or something. And we talked for a few minutes. I got off the phone. I thought, I never thought I'd be excited about spending 45 minutes trying to work Switzerland, but I was. So it's a whole different challenge than we have on the other bands. And the best practice is to work 160 in the winter months when darkness is more prevalent. There's a lot of challenges when it comes to operating 160. There's all kinds of noise. Um, when I was getting into this, Dave said, don't be surprised if you hear a lot of static and you check the weather map and the closest storms are in Kansas, you're still going to pick it up. And I think he's right. I have gotten into beverages last year, and I'm going to do it again this year. And I am shocked at what a difference a beverage antenna makes. If you're not familiar with that, it's literally just a long piece of wire that's terminated. I've done one 4 feet off the ground, and I've done one laying on the ground. The 4 feet off works better, but um, I got a lot of feedback from the neighbors, so I'll probably go with the on ground this year. Um, Typically, Joe, WAGEX, if you know Joe, he preaches 500 feet. I can't do 500, I can do 300. And what I found is if you can do 100, do 100. If you can do 200, that's better than 100. If you can do 300, it's better than 200. So that's the attitude I've taken with it. And boy, what a difference it makes. It's really a good antenna. A lot of people are experimenting with loops, literally on the ground loops, and they get a lot of good receive out of that. It turns out there's something called top band disease, and here's some symptoms. You have the desire to be on the radio at sunrise and sunset. You have the desire to be on the radio at all times between sunrise and sunset. Desire to struggle for a few months to work a single station for a new entity, and never being satisfied with the antenna system and constantly trying new ones. And that's where I find myself. I'm fortunate to have 2 acres, but I don't have, tons of space, but I'm always trying different wire configurations and things. I've never really been like that. So it's kind of cool. It's actually something that I've gotten into and I enjoy and I never really thought about before. Is there a cure for this top band disease? Well, better propagation can help if we can get better propagation on the low bands, it'll help. Um, this just strikes me because I know we've all done this. We've been up late chasing as we come up out of the shack or the basement, we're exhausted and we feel really good. Years ago, I used to chase Russian oblasts, if you remember Russian oblasts, and those were very popular at one point, and we'd stay up, well over midnight to try to catch them coming over the pole or whatever. And you'd go into school or work the next day exhausted, and yet you felt really good. So it's kind of a cool feeling. Um, I have found it to be unpredictable. Again, Dave, this KDV guy, he lives about 45 miles from me, and he's worked stuff I couldn't hear, and I've worked stuff that he couldn't hear, and that surprised me. I didn't think 160 would be that regionalized, maybe is the word, but it is consists of short hops, so that makes sense. There's lots of noise, and the people I've talked to, they will say, "Don't you need 10 acres of land, huge antennas, and noise filters?" And yeah, all that helps, but you don't need that. And then there is the threat of top band disease. So I went through that iteration. I want to share with you just a few of the 160-meter antenna attempts that I made. This was my first one, and that was really difficult to do, but it stayed up and it worked pretty well. Here was another one that worked well until my neighbor moved, and then the new neighbor didn't like being hooked to their house. This was one when we lived in the city. Didn't work nearly as well, but it was bad. This is my the one I took down a few years ago to replace with this vertical. And this is, obviously those are jokes, but this one's legit. This was at OH8X Radio Arcala. It had a 3 element, 160-meter beam. And I believe the cross pieces are Rome 45, the supports, and then the elements themselves were Rome 25. And this was just massive. And of course, storm, and this is a picture of, so there's a person in the foreground, and they did have a storm, and it did take it down. And I've never been able to find pictures of it on the ground. I was told it was a lot of twisted metal, but anyway, when it was up, I don't think there was anything they couldn't hear or work. And for a long time here in the Cincinnati area, we had Voice of America, which is down in a city called Westchester. And for years, they had big Sturba curtains and all different kinds of antennas. And one night a year, they would shut it down and allow the local 160 meter club to come in and hook up and work all night. And some of the stuff they were able to do was just unbelievable. 100 watts and working around the world. And it was just really, really cool. I tried this one for a while, and then the HOA started getting suspicious. And I thought, yeah, that's probably not a good one. Um, but in all seriousness, this was my first 160-meter antenna, and it was really, really simple. It's an inverted L, 125 feet out, which mine was, and then about 40 or so feet up. I had 8 65-foot ground rods, radials, and one ground rod, and it matched very well, and it worked very well. A very, very simple antenna. And I literally took an old dipole support, and I cut it and used that as part of the coax feed, and that's how I attached the ground radials. This was like a on a whim. There was a storm coming in, and I think the 160 meter in December contest was coming up, and I said, "What the heck? Let's put something up and see what we can do." So it is very much jury rigged, but it performed very well. And this is what it looked like, flat enough, and it really worked. Was surprised. So over the 2 years I had the inverted L, I made 1,759 QSOs, 40 entities, 15 zones, and 45 states. So I wanted to do, try to pick up a few more lots, etc. Worked well, and literally a piece that you can get out as far as you can, as high as far as you can. There were problems with it though. It was directional. It seemed to have small windows of propagation here where I'm at. It just did it. And it worked well, but I had trouble at different times hearing stations with the end of the L, the 125 feet out was right at the property line, and the rope and the counterweight would hang down, and it evidently was a nuisance for my neighbor. Don't know why, but it was. And then always I kept thinking, well, can I do any better? Can I do better than this inverted L? So what I started looking at is, I have an HF vertical ATV, and it works or doesn't work equally well in all directions, so that's okay. And the theory always was more wire in the air, the better. And the guys at work, the couple guys that work for me, started all these 3D printing projects. I thought, I think it'd be cool if I could build an antenna and somehow incorporate something 3D in it that I would design and figure out. And I started doing a lot of reading. And I'm a guy, I'll research it probably twice as much as I should before I'll actually give it a go. Um, so I started looking at this. I said, well, the quarter wave is what I had. Um, and that worked pretty well. I was happy with that. But what if I could go with a half wave somehow? So that was the goal. I wanted to get 256 feet of wire in the air. My dad, KDWE, and I built a 20-meter half-wave helically wound antennas in the 70s for a nun who was doing missionary work from the high school close to us. And she had really no room for anything. And my dad had said, "Hey, let's try this." I used to do things like this on 6 meters, and we did it, and it actually worked. It worked pretty darn well. I thought, well, why not for 160? And as soon as you search 160 helically wound, K6MM comes up. But I needed more details. So I decided, what are my requirements? Well, I wanted a proven design. I wasn't into, trying to create something mystical that might work if I had the right matching sections and networks and things. Have to have readily made materials. I didn't want to have to go, machining platinum or something. Had to work in the space I have, and I didn't want it to break the bank. And a shortened vertical, a helically wound vertical might meet these requirements. So I started looking into that. And there are multiple components of a shortened vertical. And some of those are the capacitant hat or the top hat. And this does have a top hat on it. As it turns out, my top hat happens to be the resting place for a Cooper Hawk. So it's somewhat bent, and I need to take it down and straighten it out and reinforce it. But he's happy with it, and it keeps the rodents away from the bottom of the antenna. So I guess it's okay. The capacitive hat is essentially a network of wires that are placed at the top, either to increase the bandwidth or to lower the resonant frequency. And the experimentation I did with the top hat on mine, it increases the bandwidth more than it lowers the resonant frequency. It doesn't radiate a significant amount of signal, but it does increase the effective height, which you'll see in a minute is very important. If you have no hat, RF current in the antenna decreases toward the top, and the upper portion of the radiator puts out very little signal. So it kind of doesn't make sense to get it up in the air if you're not going to radiate from it. Um, Increasing the effective height of the antenna also reduces the losses caused by nearby shrubs and buildings. And again, I have some pictures of some really interesting installations where people have done this. And I had never futched with a capacitive hat before. I found that really fascinating, changing it, trying different materials, different sizes. Um, I should go back one previous. The next part is the actual earth and the radials that make up the ground plane. Power is lost in the earth very near the antenna before it can be radiated. Um, so what we want to do is try to reduce that loss, either through a counterpoise or some radials. Um, and they'll make the most difference with poor soil. So if I'm in saltwater, I really don't care. But here in Ohio, the ground is not very good. So I had to take that into account. Um, K9YC, who I told you I read a lot of his stuff, he was very, very passionate about don't let the perfect become the enemy of the good. You know, don't do the math and say, I got to have something that's this long, but anything I can put down is 10 feet less. It doesn't matter. Put it down 10 feet less and use it. So I kind of started getting away from that into more of an experimenter mode, I guess. The radiated signal is reflected by the Earth far from the antenna. The reflection adds to direct the signal. It shapes the vertical pattern, and better soil helps lower the angle. And of course, the lower the angle, the better. If you've played around with verticals and things, they do have a good takeoff angle and receive angle, and we want to do what we can to do that. They do strengthen the radiated signal that does get reflected, which in my mind always meant I wanted more wire out there, not less. But that's not necessarily the case. So here's where the earth actually comes in. And of course, the purple being salt water. I think you guys are in the green, the very good soil out there, I think. And we're more in the rocky, sandy soil. So we've got kind of a challenge here. Maybe closer to average, but still it's kind of a challenge. To achieve the most radiation resistance, we want it to be taller. And as you increase the height, the radiation resistance changes, and that's a good thing. And it matters because the part of the feed point impedance that accounts for radiated power is the radiated radiation resistance. And we want that to be a low R so that we're actually generating more signal. It's determined by the vertical height of the radiator. RR is good resistance, larger is better. So as I said earlier, the capacitive hat helps this thing to be electrically taller. So that actually enhances this effect. The ground resistance combines with the wire resistance to burn transmitter power, and it's a simple circuit that looks like this. So what we want to do is, of course, we want to increase the radiated power and we want to decrease the ground loss. It depends on the nature of the earth around the antenna, and we can't change it except by moving it. I thought about a saltwater moat around my house, and I thought, well, that was probably a little extreme. So I'll just go with what I can. And you can reduce the ground resistance by using more radials, a good counterpoise, or a ground screen. I didn't want to use a ground screen, but interestingly enough, I mentioned Voice of America, and they literally had 38 square miles of copper chicken wire underneath all those antennas they had. So they didn't just have radials, they had an entire screen underneath it. Of course, if it's our tax dollars, so they can do those things, but it's really kind of pretty cool to think about. So if I have a tall antenna and good radials, let's say, I might see some sort of a resistive balance in a series circuit that looks like this, and I can translate that into power out. So I'm going to actually, out of 100 watts, I'll generate 81 watts, and I'm only going to burn 17 and 19.4. I'm only going to lose 19.4. So um, not too bad. I can get out 81 out of 100. If I start losing that, I'm increasing my ground loss, etc. Now all of a sudden, that whole circuit changes, and now I'm burning these resistors, so to speak, are getting hot in the wrong place, and that turns into just the opposite. I'm burning up 82 watts, and I'm only radiating 17, which is one of the challenges with a short antenna. And this is really what I had in mind. I thought there's no way this can work because of this. I kept thinking I'm going to basically be cooking earthworms all the time instead of working, having QSOs. Um, I got to take a drink. Sorry. Overall, Earth is a relatively poor conductor. Even the best connection to Earth is bad for an antenna as it drives current into the lossy Earth. So we want to make sure that we handle that, and radials will help us do that. An ideal radial system shields the antenna from the Earth. It provides a path for the return current. A counterpoise provides only the return path, and we'll touch on counterpoises later. It's 10 o'clock back here, so that's a good excuse. With no radials at all, the outside of the coax forms a single radial or counterpoise. And that's why if I built some verticals years ago in the dark, I was putting them up, I didn't pay attention to the actual ground that was not connected to the ground rod. And as soon as I threw any power on it, the shack objected to it, and it's basically because all that RF was flowing back at me. So I take a little more time now when I do this stuff. Guidelines for all radials, and this is from K9YC. He uses insulated wires simply because it holds up longer. He uses number 18. Large spools are hard to buy, and the cost of wire is just nuts right now. It's better, but he recommended, I don't know what it stands for. I did look it up, TAHN, which is like a standard housing wiring, I guess. It works well. Sometimes you can find large spools of it. I did find about a 400-foot spool of it at a Home Depot. They discounted it a bit because it was part of a 1,000-foot roll, so it kind of worked out better, but I had done a lot of searching to find it. Um, the work that K9YC did is that he found the best would be up to 60 quarter wave laid out as symmetrically as you can. That would be best. Very good. Would be many wires on the ground and the lengths can be random. Symmetry is good, but most radio systems must be shorter in some directions because they run into building roads or property lines. And I don't know how many of y'all have enough space where you could lay out, basically a 200-foot diameter circle. And if you do, that's great. I didn't have that, and the purpose of this was not to do that. So some traditional radial systems that I looked up, 60 radials, each 100 to 25 feet long, arranged symmetrically right around the feed point. So again, an open space with 100-foot radios, so you're talking about a 200-foot diameter circle. I'm not able to do that. Few city and suburban lots are typically 130 by 40. Now, I imagine out there it's probably different. But I did look this up in Hamilton County in Cincinnati, a typical suburban lot is usually more like 130 by 60. So still not large enough for a full-size ground plane. Most of us need a plan B or a plan C. So what I found out and tried and use is use as many radios as you can, each as long that'll fit in your space. Use a ground screen made from galvanized hardware cloth. I did not do that. As large as you can reasonably fit. Now, a couple of the ones I'm going to show you in a minute, they did do this and it worked really well. I didn't. Don't use radios longer than the vertical height of your antenna. Now that surprised me. Now this is K9YC. This is his research and what he recommends. So you're going to see if you have a 30-foot tall antenna, your radio should not be any longer than 30 feet. And he's got the math behind it to prove that. I was really surprised going through that. That was just never something that it didn't resonate with me, to use a term, right? Um, Current distribution causes longer radials to not work very well. If you want to use more wire, add more radials, not longer ones. And I think the rule of thumb in my head was always, if I could go a half wavelength all the way out or a full, that would be better. And it's turned out that that's, in his opinion and his research, not necessarily the case. And it has been what I have found as well. It's better to have a more shorter radials and a few long ones. You can never have too many. Start with what you can now and add more when you can. And I did start out with 8 and I went to 16. I'm at 32 and I started to go to 64, but between 16 and 32, I didn't get a whole lot of return, and I really didn't think that the going 32 to 64 would be worth it, so I stopped at 32. So all that stuff being said, I told you we're going to take a couple different guys' stuff and we're going to bake a cake, and that's what we're going to do. So let's see how you build this thing and what it looks like. The original article appeared in QST June of 2009 by John Miller, and he called it the No Excuses 160-meter Vertical. And this is what it looks like. There are 3 pieces of PVC that go inside of each other for a total of 27 feet. A half wavelength of wire is helically wound, which you're just spinning it along it. So you get 256 feet 5 inches at 1.825 megahertz. I use number 14 wire with a capacitive hat. I feed it with 50 ohms. It matches really well. And I didn't update the slide. I now have 32 30-foot radials. But that's what it basically looks like. It's 27 foot tall. The construction of it was very simple, and we'll go through the quick painting, the bottom section, wiring the coax connector, et cetera, et cetera. And if you're handy at all, this will be good. And one of the best tools I had was a couple of grandkids that were eager to help me. So I let them do the spray painting of the 3 sections, and they were happy to do that. And before you ask, yes, I can ship these guys out to you if you want to build this. They can paint it, and there's a few other things they can do with it. So don't hesitate to ask. You may have to feed them, but other than that, they do a good job. The bottom section where the coax attaches, it's really simple. I just used a couple of lugs and a coax connector like that. On the outside, it looks like that, and inside, I just grab the center portion and put it right here to the black binding post. So I'm sorry, yeah, the black binding post. I knew I was wrong. The red binding, of course it was red. So the center goes to the red binding post, the ground goes to the black one, and we're off and running. That is literally all there is to the matching connection section. The three sections themselves, the PVC, I use Gorilla Tape to wrap around it so that when they slide it in, it's a little bit snug. This stuff's amazing. Once it absorbs moisture, it locks that in, and it's really hard to get the sections apart once that tape swells and locks in. Um, I was kind of surprised how well it worked. Um, what I did is, if you recall, I said I wanted to do something with a 3D printer. And as I started winding this thing, and I'm using number 14 wire and it's insulated, that stuff has a mind of its own. So you might turn it and turn it and turn it, and as soon as you give it any slack, it wants to spring back on its own. And then all the sections slide together. So then I started taping, and I thought, this is stupid. What if I just came up with a wire guide? So that became my, I'll show you here, that became my 3D project. I created a wire guide for the side of it. And it took 40 of them because it's 27 feet long. So I printed 40 of these and just put them one after the other down the antenna and just wound it. And it held, of course, it held everything in place. I still use tape like at the beginning and at certain points where I had to stop and rearrange the wire and things. But this is essentially the feed point here, and that's where the wire connects at the base, and I just wound it all the way up. And because I'm the way I am, once I wound it, I did go back through and straighten it up a little bit and try to make it look a little cleaner, I guess. And that's what the sections look like as they all start to come together. Um, and I just put those all the way out and wound it, and I got all 257 feet of wire on there. Here are a few other ones. John K6MM tried it with network cable. He had a couple of 100 feet of network cable, and he just shorted it at one end and the other, and he wrapped the whole thing, and he just used a hot glue gun that his wife had, and he glued it in place so it didn't move around. This is the top hat, and it is just a cap, a PVC cap that I drilled through with brush rods and put the PVC cap on the top. And I actually put a screw in it. Um, and over here on the right is the actual hat. And the one I have now is a mess. As I said, there's a Cooper Hawk that likes to sit on it. I didn't realize how much they weigh, but he's had an effect on that. So hopefully in the next couple of weekends, I'll get it down and straighten it out. And that's with the hat on. And then the actual braid comes out that connects the hat to the end of the wire. And there's another view of it on the right. And that's looking toward the base of the antenna up toward the top. And that was before I put the center part of the hat in. But anyway, that's what it looks like. And then the actual bottom cap. Now I've gone away from this. John does it this way. He takes another cap, plumber cap, and he put a 18-inch screw rod in there, and he would just walk it up and drive that into the ground and use a couple guy wires. And what I found, of course, Murphy's Law, the first couple places I tried, I hit rocks and the screw bent and it was a mess. So what I ended up doing was I shifted the Hoy antenna a little bit so there was about a foot left over at the bottom of the PVC. And I dug down and I just set that in there. I packed dirt around it and I used the guy wires to hold it in place. It works perfectly fine. I'm a little surprised after 3 years how brittle the PVC is. And I'm concerned that when I take it down to fix the capacitive hat, it's going to break. And then I'll just have to redo it. But fortunately, it's just, PVC pipe. So this was the initial one I put up, the SWR curve. It's not quite as flat as I'd like it, but it gets me down into the sections where I really want to work. It works really fine. And this next one I put up, I'm going to play with the hat a little bit to try to flatten this out and or move it just a little bit. So in the couple of years I've had it up, it's almost 4 years now. I've made 1,355 QSOs, 61 entities, 16 zones, 48 states. And I got a really good comment back from NSV who was, hey, it was during the 160-meter contest, but he wanted to know, what are you running? And that was kind of cool because I thought, well, it's just pipes with wires on it. And he wanted to know what I was running. And I was able to work Japan and Australia. Now, I know a lot of that is due to propagation and may or may not have anything to do with the antenna, but um, I was able to work that and I was happy with that. I don't know that Japan and Australia is maybe as rare for you guys, but for us out here, it's not common at all. So here's some of the folks I've worked with it now that I've had it for 4 years. I've had good results with it. I've been very, very happy with it. It doesn't have a huge footprint. You can see I've kind of worked all over the place now. Still don't have 100. I'm at 61, but that's okay. We'll get there. The very first night, though, just for fun, I used FT8 on the antenna, and I went from about, if I recall, 7:30 to about midnight, just tinkering with it and doing some SWR sweeps and maybe some plans. And these are all the states I worked the first night. So, again, it's not setting the world on fire, but I knew I was getting out. I knew it was working. Maybe with better conditions or more power than 100 watts, I could do better. But I found this to be very encouraging. This is the antenna. This is the woman back here on the right that doesn't like ropes. So I wanted to put her in the picture. That's the antenna right in the middle, and it's straighter now than this picture. The guy wire stretched a little bit that I used, but it's right there. It's 27 feet tall. It goes a little bit higher than this, but it doesn't stick out as you can see. It's just back there. It works. It works pretty darn well. Now here's some other implementations that have used this, and these are all on John's website. Scott, VE1CHL, he has this, and you can see it's right up against a building, um, and it works really well for him. ND7J Bob, this is his implementation, and he didn't worry about painting or anything. He just put it up, built a nice fixture for it to hold it in place. He's down in Tennessee, and it's worked very well for him. Oh yeah. Oh, I forgot. See, I forgot. I sent him an email because he saw this discussion at SEDCO, which is the W4 DXCC that's in Pigeon Forge, and he asked me, "Can you send this to me?" So before I did this presentation last time, I sent him an email and said, "Hey, how's this going?" He said, "Oh, he worked two new countries, Kuwait and Bonaire, and he decoded a VK but didn't work them." This was several years ago. Overall, he would say it was working, and he sent me a nice picture of the power out and how it's in his implementation of it to the right. So it works. This is Arkansas. It's another implementation. I wouldn't have the guts to do what this guy did. He used his circular saw and notched it. I think I'd have lost a finger or two by the time I was done, or the pipe would have been dancing all over the garage. So I didn't want to do that, but he did, and it worked for him, and that's great. Gail in California built this one. This is a guy in Indiana. I actually went past his house several years ago and I didn't see it. So I don't know since he sent this to John if he's taken it down or he moved or something. But you can see, I mean, you can see the wire even wrapped around it. It looks like he's using tape to hold it in place, and that's up against the fence too. Um, and he says here he's very pleased with it. And here's one that's up against a deck. So I didn't feel too bad about, well, let's put it up and see what happens and go with it. He uses 5 radios lying on top of the ground. Here's another one. So a number of people have built this. This is the one that I was most intrigued with. Um, I couldn't wind that if I had to, and that looks like a coil that he bought somewhere. That was really well done, um, and I thought that was pretty cool. But again, it's kind of the same design, and it's just wire in the air. If you allow me, there's 3 quick shameless plugs. If you listen to podcasts, I do have something called the DX Mentor podcast, and my friend Ned's been on it several times. And I try to get people on. I find it very interesting. I've learned a ton. We also have a YouTube channel called the DX Mentor. I have a lot of guests on there. I'd like you to give that a listen. And then every week on Saturday morning, I push out a This Week in DX, and it's pretty much Bernie, W3UR, allows me to do a video discussion of what should be on the air in the next 7 days. He's been very generous with that. So just 3 shameless plugs for me. So do you have any questions? That's what I have.
Back to a live mic. Hopefully you can hear this. Questions? Ned's got questions.
Oh, no.
There's an easy one. It's just chart. I couldn't read it from back here in the room. What's the bandwidth, the 2-to-1 bandwidth on that antenna?
Yeah, let me go back to it if I can. Let's see. I think P. Bear with me for a sec. Oh, it always happens. So 2-to-1 would fall right about, if I'm looking at it, 1.87 maybe, something like that.
So 1800 to 1870?
Yeah, I'm sorry. Yeah,
That's good.
about.
No, that's it.
Okay.
Bill, this is
Yes.
Israel K7NO.
Yes, sir.
Can you repeat the dimensions for the cap hat?
I don't think I set them. The one that I currently have, yeah, I don't have that on here. The dimensions I have, they're 18-inch brass rods. So it's a square that's 18-inch diagonal. And then inside of it, there's a loop inside of it at the 9-inch point, and then there's a loop on the outer edge. And I
Okay,
do.
and did you use just regular, rods that you can buy at Home Depot
Yep, that's
or spec? Okay.
and yeah, and it turned out I went to Home Depot and Lowe's, and I couldn't find brass rods, but I did find them at Ace. We have Ace Hardware out here, and they had them. And yeah, that's what I used. And they actually have 18-inch rods, which is what John had originally called out. So I just used those and put them, formed an X through the top hat and soldered them together. And if anybody's interested, I can send you the article with the details that I've added, as well as if you're into 3D printing, I can send you the STL file too, if you think that the wire guide would help you and it's something you're interested in. The big challenge for me simply was, you're trying to wire a 27-foot long pipe basically that you have spray painted with slippery paint, and that plastic insulated wire was just dancing everywhere. So I had to do something, and that's why I used the wire guide.
So your QRZ email address is good. I can, shoot you an email from there because I would like to have that.
Yeah, in fact, if you're good, I'll send it to you as soon as we're done here. K7NO.
All right. Correct. Yes. Thank you.
Yeah,
Good presentation. I
to do
really
it.
love the presentation.
Hey, Bill, John
thank you.
John N7NWL. If you would also email that information to president@cadxa.org, I will add that to our collection of goodies, and I can forward it to our members as they want it. As president
happy to do
at
that.
cadxa.org.
CAD, yes, sir. Yep.
Okay, any more questions from the folks in the room? No more questions there. Okay, we got some folks on Zoom. Israel, you've asked some questions. Mike, KC7V, have you got anything? Ray, Tommy? Anybody else got any questions from the Zoom group?
I already asked my questions, but thank you, John, for opening up the opportunity. Thank you.
Okay, Israel. Well, this mic's working and the cameras are all working and all that, so I kind of like to take the opportunity to talk way too much. But anyway, Bill, that seems to take care of the questions. It was an excellent presentation. Thank you. And I will get that information where our members can all find it, and they can kind of take it from there.
Okay, thank you for having me. It was an honor and a privilege. And if I went a little bit fast, it was because I know you guys have a hard deadline there. And the last thing I wanted to do was go over it. I have a tendency to go down rabbit holes. So I went a little faster than I normally like to, but I didn't want to make you late. So
No,
I really do appreciate the opportunity to do this. And
I appreciate that. And yeah, we're just restricted on time because that's the way it's set up. But anyway, you were perfect. That was excellent and tons of information. I wrote down notes that I won't be able to read, but I'll digest them later on. Anyway, thanks, Bill. 73, my friend.
All right. Thank you all.
Okay, thanks. And Bill, if you would
right,
unshare, please, sir, then that will take it back to something I can break, and we're going to do a 10-minute break for cookies and stuff like that. Thanks, Bill. Appreciate it. 73, my friend.
Thank you very much.